here we're going to look at a graph and we're going to try to answer some questions about it. So first thing is, when is it increasing? So when you're looking at your own, it'll be a little bit larger. So it's going from negative infinity up to increasing up to that maximum, -8. I believe they also have kind of multiple choice here. So you don't have to come up with the cutoffs yourselves, but you can see them better on the actual graph. And then it's increasing, so going uphill from here to here. So that looks like it's from -5 to -2. Then it goes downhill, and then it goes uphill again from what looks like 2 to 5. And then it goes down again, so we should have 1, 2, 3 areas where it was increasing. And so just make sure you check all of those. All right, then it wants to know, where are the local maximums? So where are these top of the hill points? So it looks like, and when they say where, that means what x value gets you there, not what is the actual maximum. So it looks like one maximum occurs here at -8. So they're asking for where are the maximums. So one maximum happens at -8. Another one, this point here, looks like it's at -2. And then the other one, this point here, looks like it happens at 5. And you notice, not coincidentally, those were the cutoffs where it was increasing, decreasing, because it increases up until it hits the top of a hill, and then it's decreasing. All right, then they want to know, is our leading coefficient positive or negative? What we're looking at for that is this end behavior stuff. So notice this one I know has an even degree. How do I know that? Because it goes off in the same direction. So think like a parabola, like x squared versus -x squared. They both go in the same direction. X to the third is where your end behavior goes in different directions. So I know it's an even degree. And so think if it's like a parabola open up has a positive leading coefficient. So this one, the leading coefficient must be negative because this opens downwards eventually. All right, then the most interesting one, they say, what possibilities of degrees could this be? Because there's a few things that go into this. First off, we know the degree has to be even because of the end behavior, just like we talked about. So we know it has to be an even degree. Move that where we can see it. So the degree must be even. So that rules some stuff out right there. Then we can look at, well, how many zeros do we have? It crosses the x-axis here, 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 and here. So it looks like there's 4 zeros. So minimally, now some of those could be bigger multiplicities, so there could always be more degree in it, but minimally, we know that our degree has to be bigger than 4, or greater than or equal to 4, I guess. Because we can see 4 different zeros, so there has to be at least degree 4 to have 4 different zeros. Okay, so then there's one more part of this where they talk about the number of maximums or minimums, or sometimes it's called the number of turning points. However many turning points you have has to always be still one, your degree has to be 1 bigger than that. And so here, if this turns 1, 2, 3, 4, 5 times, so how many of those peaks and valleys do you have? So if it turns 5 times, that means our degree has to be bigger than 5 by at least 1. So it could be 6, or it could be 8, since we know it has to be even. So picture we were down to, it could have been degree 4, 6, or 8. And because there's 1, 2, 3, 4, 5 turning points, degree 4 just isn't enough to have 5 turning points. It's got to be one more. So that narrows it down to 6 or 8. So there's a few different things that go into that. You want to look at end behavior, how many zeros do you have, how many turning points do you have, and start narrowing them down, kind of process of elimination.